For decades, dark matter has evaded our understanding no matter how advanced our technology gets. We've poured millions into particle colliders, built sophisticated underground detectors, and yet the mystery remains unsolved. But what if I told you that the key to solving the dark matter enigma could lie in something far simpler? A ray of light, a precise clock, and a planet in our solar system. Mars? Stick with me as we explore this groundbreaking possibility. Over 80% of the mass in the universe is made up of something we can't see, something that, for all intents and purposes, is invisible: dark matter. For years, we've speculated about what it could be. Some thought it might be invisible stars like brown dwarfs or neutron stars. Others leaned toward the idea of black holes lurking out there, hidden in the cosmic shadows. But no, all of these ideas slowly fizzled out. Why? Because we couldn't find any credible evidence. Have you ever lost your keys and checked every spot, only to find them in your pocket in the one place you'd already looked? It's like that with dark matter. Maybe, just maybe, we've been looking in the wrong places all along. Now here's where things get interesting. While we've ruled out a lot of options, one possibility still remains: primordial black holes, or PBHs. These black holes would have formed just after the Big Bang, under conditions we barely understand. They could have masses similar to asteroids, anywhere between 10-17 grams to 10^23 grams. But what's crucial here is that this mass range is still unexplored, and it just might hold the key to dark matter. What if the very thing we're searching for has been lurking around us all along? In fact, one of these primordial black holes could be floating through our solar system right now. Could PBHs be the answer? You see, black holes today form from dying stars, but PBHs would have been birthed in the chaos of the early universe. These cosmic relics might have been tiny back then, potentially as small as an asteroid, but powerful enough to become the dark matter we're still hunting. But here's the kicker. While we've been searching for particle-sized traces of dark matter, we might have overlooked a much larger clue: primordial black holes, potentially in the mass range of asteroids. What if the secret to dark matter isn't hidden in microscopic particles, but in something as large as an asteroid? Could our solar system be a cosmic detector, and we just don't know it? Recent studies are showing that our solar system might just serve as an enormous detector for these dark matter black holes. These PBHs could leave subtle but detectable gravitational signatures as they pass through the solar system, like faint ripples in space-time. Intrigued? So was I. Imagine trying to detect a ghost by its impact on the physical world around it. We have all the tools we need to look for these signatures: precise clocks, light speed measurements, and incredibly accurate data from the last 20 years of planetary positions. What if detecting dark matter isn't about finding the thing itself, but measuring its tiny effects on something as massive as Mars? What if we've already been looking in the wrong way, and the key to dark matter is hidden in plain sight? Let's talk numbers. In the region of the solar system where we live, the density of dark matter is about 7 by 10^25 graus per centimeters threes. That means if dark matter consists of particles the size of protons, around 10 million of them are passing through you every second. We can't feel them, but they're there in abundance. But what if dark matter isn't made of tiny particles but compact, invisible black holes? A black hole the size of an asteroid spread out across our solar system. Imagine if all of dark matter is made of invisible black holes. We could literally be walking through a cosmic web, unaware of the countless PBHs passing right by us. It's mind-blowing. But how do we detect something as small as an asteroid-mass black hole? The answer lies in gravitational lensing. When a black hole passes in front of a distant star, its gravity warps the light, causing the star to briefly brighten. This effect is known as microlensing, and it has already been used to rule out certain mass ranges for dark matter. But here's where it gets even more intriguing. PBHs could be hidden in the gaps. The mass range we're talking about, between 10^17 grams and 10^23 grams, hasn't been fully explored. In fact, the only remaining mass window open to us is the asteroid mass range. If we could find even one of these PBHs, it could solve the mystery of dark matter for good. Could we be on the verge of uncovering an invisible force that's shaping the entire universe? If these asteroid mass PBHs really are out there, we might not see them, but we could feel their presence. Imagine a PBH passes through the solar system just outside Mars's orbit. The tiny gravitational influence would be so subtle that it could alter Mars's orbit ever so slightly. Over years, that slight change could add up to a noticeable deviation in its position. And with the precision we have today, that deviation could be measured down to the millimeter. Mars, a planet over 200 million kilometers away, could reveal the truth about dark matter. How? Through its movement, its dance with gravity, and the ghostly traces left by an invisible, asteroid-sized black hole passing by. Here's where it gets even more exciting. While we can use data from Mars' past to look for signs of past PBH flybys, the real breakthrough could come in the future. With more data and advanced simulations, we might be able to track the exact path of a PBH as it coasts through our solar system, altering planetary paths in ways we never imagined. But it's not just about finding one. If dark matter is made of primordial black holes, there should be a lot more of them, and detecting multiple flybys could provide the final confirmation. So here's the million-dollar question. Could we really detect dark matter by watching nothing? If the solar system is filled with countless asteroid mass PBHs, we could trace them by the subtle shifts they cause in planetary orbits. And that might just be the answer we've been searching for all along. What if the key to solving dark matter isn't about looking harder for particles, but about watching the slow, tiny shifts in the universe itself? Maybe, just maybe, the universe is already showing us the answers. We just need to know how to read the signals. In this grand cosmic detective story, we may discover dark matter not by finding it directly, but by feeling its subtle fingerprints in the motion of the planets. Thank you for joining us on this journey through the stars. Don't stop here. Subscribe for more cosmic adventures. Together we'll unveil the secrets of the universe. Until next time, keep your eyes on the skies. Keep stargazing.